Hello, second graders. I'm excited to be back with you again today. My name is Mrs. Smithy and I teach second grade at Stockwell Elementary. We are on day 7 or lesson 7 of our summer math series, and you are going to need today your guided worksheet that has day 7 at the top and your pencil a little bit later. So go ahead and get those things. And our code word today is compare, C-O-M-P-A-R-E, compare. So go ahead and write that down as well. We're going to start today with something I like to do with my class. It's called a body scan. And this is something that you can do when you need to relax and you're getting ready to focus on something, or maybe you're upset and you need to calm down. It's just making yourself aware of your body and making those tense muscles relaxed. So we're going to actually start at the bottom and work our way up towards our head today. And we're just going to think about each of these parts of our body and how they feel, and we're going to be mindful about them. And if they do feel stressed and kind of tense, where your muscles feel tight, you can try to relax them, and that'll kind of help with your breathing and get you ready to learn, okay? So we're gonna start with our feet and our toes. So I want you just to, wherever you're sitting or if you're standing, think about your feet and your toes. What do they feel like right now? Are they tingling? Are they warm or cold? Are they curled up real tight? If they are, then just kind of relax them. And then move up to your knees. So what about your knees or your legs even? Do they feel real tight? Are your legs crossed? Maybe you need to uncross them to kind of let that blood flow through them. What about your chest? This is where a lot of people carry a lot of their stresses in their chest. If your chest feels really tight, just take some nice, relaxing breaths. And then go ahead and think about your fingers and your hands. If your fingers are all clenched into a fist, sometimes that gets real tight. Just relax them. Go ahead and move on to your shoulders. If your shoulders are tight, sometimes you want to give them a few rolls backwards, or maybe they're like up high like this and you don't realize your shoulders get like that. You just want to relax them and kind of roll them back. Same with your neck. You may want to kind of move your neck. And then think about your head and your mind. What are you thinking about? What are you focusing on? Something may have happened and it's hard to get out of our head, but we're going to try to block out any distractions and be able to focus on our lesson today. Thank you for doing that body scan with me, and that's something you can do wherever you're at. It's a tool that you can use. And we're going to jump into our target today. We are still working with word problems, and these are some of my favorite word problems. I know some people think they can be kind of tricky, but I'm going to teach you a way to break it apart so that you can tackle these kind of problems. And you've already learned some tools with our other lessons that will help you today. I can use addition and subtraction within 20 to solve real-world problems. I can represent my answer using drawings and equations. And again, we're just going to be finding information in a problem to help us answer a comparison question. And then we're going to use evidence to prove our answer, and that could be showing strategies, using those bar models, any way we can prove to show our thinking. So before we start talking about comparison problems, we want to talk about that word compare. What does it mean to compare something or compare two things? Now, I know in second grade, we did lots of comparing and contrasting stories and reading, and we made Venn diagrams. Well, we can compare things in math as well. When you compare something, we want to see how they're the same and how they're different. And we're going to use some blocks today just to kind of practice comparing before working on our word problems. What I'm going to do is I'm going to grab these blocks 2 times, and we're going to compare grab 1 with grab 2. We're going to see how they were the same and how they were different. So I'm just going to reach in. I've got my tub of cubes or blocks here. I'm going to grab one time. Let's see how many I can grab. I'm just going to put them here on the table. And it looks like I grabbed 1, 2, 3, 4, 5, 6. So I'm actually going to go ahead and draw 6 cubes in here. 1, 2, 3, 4, 5, 6. And then I'm going to grab the second time, and I'm going to maybe put these on this side. I'm going to grab one more time. This time I grabbed, how many did I grab? 4. Okay, so I had 6 on my first grab, and I had 4 on my next grab. Now, we're actually going to go ahead and draw these on the next slide, and I'm going to line them up, and we'll be able to compare them a little bit easier. So do you remember what I grabbed on my first grab? Six cubes. And how many did I grab the second time? 4, right? And you can kind of see now I've lined them up. When we compare these, we're going to see how they're the same and how they're different. So just by looking at our little chart we made here, I can see that grab 1 was, what would I say maybe in that blank? A word that we could use to compare. Grab 1 was greater than grab 2. Do you agree with that statement? There's more, so it's greater. Or we could say grab 2 was less than, because there are fewer. So those words, less than, greater than, more, fewer, those are all words we use to compare. Now I have a picture of a very helpful tool that you may have seen in your own classroom. Do you know what that's called? Right, it's called a scale. And I happen to have a scale right here. Now, what do you use a scale for in your classroom? Just think about that, or maybe a way that you have used it before. And I want you to think, if I'm going to put my blocks from each grab into one of these buckets, how can this tool be helpful? What can this tell us? But then also think about, what can it not tell us? Well, just by looking at it, you're probably telling me through your TV, there's more on this side. How can you tell there's more? Because it's heavier, and so the bucket goes down. Or you may say there's less on this side because it's higher. Now, a scale can tell us like this, which one's heavier, which one's lighter. There's more on this side or there's less on this side. But what it can't tell us is how many. We need to figure that out today ourselves. And we're going to be doing addition and subtraction to figure out how many more or how many less there are. All right, so thinking about our cubes again, I'm going to go ahead and draw these up here quickly. We had 6. We're going to be thinking about how we can compare them. How are these the same and how are they different? Well, we know that they both the times I grabbed, we had at least how many? 4. So that's something that was the same. What about the difference between the two? And you've heard that word difference before. We're going to talk about that in a minute. What's the difference between grab 1 and grab 2? How are they different? There's 2 extra here, right? So 2 is the difference between them. So if we want to figure out exactly what that number is, I know you may have already counted these, but if you're using bigger numbers, we wouldn't be able to draw all those up there. We can use an equation to find out the difference. We can use subtraction by taking the most that we have, which was 6, And we can take away what was the same. Do you remember how many we said was the same with both grabs? 4. So if we take away the amount that were the same, we're going to be left with the difference, the extra. 6 minus 4 equals 2. Is that how many cubes we had? Yes. So we could also use addition. This looks familiar, right? Kind of like what we were doing with our other word problems. We can take the amount that we know is the same. So we had 6. And we think, how many extra are there if we know that the largest amount, 6 wasn't the same. I bet you're telling me that right now. 6 wasn't what we had the same. 6 was the most that we had. Erase that. The most that we had was 4. Or I mean the same that we had, the things we had, the cubes that we had were the same, were 4. 1, 2, 3, 4. So we've got 4. How many do we need to add to that to get to 6? So we were short how many? Well, we know 4 plus 2 equals 6. So we know the 4 that were the same, the difference between the things that were the same and the most is 2. So we can make a comparison statement here too, kind of like what we did on the other page. We could say grab 1 is how many greater than grab 2? Grab 1 was 6, grab 2 was 4, so we could say grab 1 is 2 more than grab 2. We also could look at it and say grab 2 is what? Is 2 less than grab 1. Okay? When we compare things, we just look at how they're the same and how they're different. And then in comparison problems, we're going to have to find that difference between the two. I want you to think about this problem we're going to watch about Maya and Brian. And I want you to think about which way you would solve this comparison problem. They each solve it a different way.
Maya uses a part-part whole mat to figure out how many more stickers she still needs to get a prize. She has 7 stickers. But that's only part of the amount that she needs. The whole amount she needs is 10 stickers. She knows that the other part represents the amount she needs to earn a prize, but she doesn't know how many that is. Maya decides to think about the situation by counting up to figure out how many she still needs to earn. She writes the number sentence, 7 plus something equals 10, to show the situation. Next, Maya counts up from the 7 stickers she has until she gets to 10. She starts at 7 and counts 8, 9, 10. That's 1, 2, 3 more stickers. Maya just needs 3 more stickers to get a prize. So 7 stickers plus 3 more stickers will equal 10 stickers. Looks like Maya needs 3 more stickers. Later in the school year, Mr. Nelson tells his students that they will need to get 20 stickers to earn a prize. Maya thinks that's more than they had to earn before. Later, Maya and Brian decide to compare how many stickers they have. Brian has earned 16 stickers, and Maya has earned 7 stickers. Maya wonders how many more stickers Brian has than her. Brian suggests that they compare what each of them have. How can they compare their amounts to find out how many more stickers Brian has than Maya? What are some equations they can use to show the comparison? You know how to compare numbers. Let's compare numbers in a situation to find the unknown. Maya decides to solve this by lining Brian's sticker chart up right next to hers like this. Then she compares and sees that this represents how many more stickers Brian has than her. Maya counts up to see how many more stickers Brian has. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like Brian has 9 stickers more than Maya. Now Maya needs to write her equation. She writes 7 plus something equals 16. The 7 shows Maya's stickers, and the 16 shows Brian's stickers. The question mark represents how many more stickers Brian has than Maya. Since Maya figured that out, she replaces the unknown, or the question mark, with the 9 that she counted up earlier. And her final equation is 7 plus 9 equals 16. Brian uses a part-part whole mat to organize his thinking. He knows that Maya's 7 stickers make up only part of his 16 stickers, so he shows Maya's 7 stickers in the part section, and his 16 stickers in the whole section. Brian just doesn't know what the other part is. He decides that he will subtract to figure it out, and he puts a question mark here in the part-part whole mat. If he takes 7 away from 16, he knows he will find the other part, or the difference between his number of stickers and Maya's. There are 9 left. So that must be the difference between Brian's stickers and Maya's stickers. And Brian uses the equation 16 minus 7 equals 9 to show this. Even though Maya and Brian used different strategies and equations to show how they compared their number of stickers, they both found that Brian has 9 more stickers than Maya. We can describe the meaning of addition and subtraction in comparison situations. The values in an equation can be compared in order to understand the meaning of each value.
All right, so from this next part, you are going to need your guided worksheet and a pencil. We are going to work through a couple of these problems together today. And we're going to use what we talked about with comparison models. We're going to use that in a word problem situation. So just like usual, we're going to read the word problem. We're going to find the question that we need to answer, and then we're going to chunk it to find that information, okay? Sandy has 16 marbles in her jar. Mark has 3 marbles in his jar. How many more marbles does Sandy have than Mark? So what is that question they're asking us in this first problem? How many more marbles does Sandy have than Mark? So who has more marbles? Can we tell just from this question? Yes, it says, how many more marbles does Sandy have? So that means we know Sandy has more. So we should be thinking about, is this reasonable as we work through this problem? If you end up having that Mark has more marbles, that doesn't make sense with the problem. So let's go ahead and start at the beginning. Sandy has 16 marbles in her jar. So I'm going to use a bar model. If you want to use a part-part whole model, you can. I'm going to go ahead and make a bar for Sandy. I'm just going to put an S here for her. And we know she has 16 marbles in her jar. Let's keep reading. Mark has 3 marbles in his jar. So let's draw a bar for Mark. On your paper, go ahead and draw with me. Now I know it'll be shorter because Mark has less, and in fact, it says he only has 3. So the question is asking us, how many more marbles does Sandy have than Mark? So how many extra does she have? We're going to find this missing part. This is the extra that Sandy has that Mark does not. This should look familiar, and we should be able to create an equation from this. We have 2 parts now, and we have a whole, and we are trying to find that missing part. So an equation that we could use, that we could write to represent this model could be addition or subtraction. What kind of subtraction equation could we write? We could take our whole 16, subtract the part we know, 3, and we'll be left with the extra. So we know that Sandy had 16. If we take away the 3 that Mark has, we'll be left with how many extra Sandy has. Or we could start with what Mark has, which is the same that Sandy has. They both have 3, but Sandy has extra. So we could start with our 3 and say, what do I need to add to the 3 to get 16? Now remember, x is just our missing number. That's what we're trying to find. All right, so now we have our equation. We created our model, we got our equations, and now we have to calculate our answer. So 16 minus 3. If I start with 16 and I take away 3, what would that be? If we start at 3, how many do we need to add to get to 16? Did you get 13? 13, what would be our complete answer? 13 marbles. Is this a reasonable answer? Well, let's see. Let's plug this answer in right here. So if x is really 13, that means Mark has 3, and if he were to have 13 more, would he have the same as Sandy? Yes. So Sandy has 13 more marbles than Mark. That makes sense. That's a reasonable answer. All right, let's go to the next one. We'll read it through once, and then I want you to find that question they're asking. Kylie jumped into the pool 18 times, while Gabby only jumped into the pool 14 times. How many fewer jumps did Gabby make than Kylie? What is the question we are trying to answer? How many fewer jumps did Gabby make than Kylie? So we already know who made fewer jumps. Gabby. We just need to know how many fewer she did. So I want you to go ahead and read the first chunk. Kylie jumped into the pool 18 times. Then go on to the next chunk. While Gabby only jumped into the pool 14 times. Go ahead and try to draw a bar model or a part whole model on your paper that you think would represent what's happening in the story so far. Okay, it told us that Kylie jumped into the pool. I'm going to put a K for Kylie. How many times? 18. Gabby only jumped into the pool how many times? 14 times. So we're going to make her bar a little bit shorter, and we're going to put 14 in there. Is that what your model looked like? Or if you had a part whole model, your whole would be 18 and part of it would be 14. Because our question asks us how many fewer jumps did Gabby make than Kylie? So we want to know how many fewer Gabby made than Kylie. Gabby didn't make 18, she only made 14. So how many more does she need to have is that question we're answering. So we need this to be our missing part that we're solving for. I'm going to put an X in there. All right, now use your model to write an equation. If you want to do the addition and the subtraction, that's fine, but go ahead and write an equation that represents this model. Remember, you can start with the whole. The larger amount is 18. If we subtract the part, which is 14, we know Kylie jumped 18 times. If we subtract the 14 times that Gabby did, we should be left with how many fewer Gabby jumped. She needed to jump this many more. Or maybe you chose the addition equation. Maybe you started with the 14 and you thought, how many would she need to jump the same as Kylie? Even though that x is in different places in our equation, it's still going to answer that same question. All right, now that we have our equations, go ahead and find your answer. What number is that x? Well, if you had 18 and you took away 14, so if you took away 10, that would be 8, and you take away the 4, that would be 4. Or you may also know that you need to count on 4 more from 14 to get to 18. That means 4, label your answer, jumps. Gabby made 4 fewer jumps than Kylie. Let's plug that in and see if it's reasonable. Okay, 14 plus 4 would have given her 18 jumps, just like Kylie. Yes, that's a reasonable answer. All right, last one. There are 12 boys signed up for summer camp. There are 15 girls signed up as well. What is the difference between the number of boys and girls signed up for camp? There's that word difference, just means what is the difference between the two? What's that missing part? Go ahead and find that question. And then chunk it and create your model. There are 12 boys signed up for summer camp. There are 15 girls signed up as well. I'm going to draw my model for the boys. There's 12 boys. And my model for the girls, there's more girls, so I'm going to make my bar longer. If we want to know the difference, that means we need to know this missing part right here. This is the difference between the boys and girls. They both had at least 12 signed up, but the girls had 15. So what's the difference between them? Go ahead and draw or create your equation from that model. (15) minus the 12. Our whole is on the bottom here, but does that matter? No. That's still our whole. We're still trying to find that missing part. Don't let that throw you off. Maybe you used addition. 12 plus what would equal 15? What does x equal here? (15) take away 10 would be 5. Take away 2 would be 3. Also, if we start at 12, we know if we count on 3 more, 13, 14, 15, that would give us 3. So 3 is the difference, and that would be a reasonable answer if we plug that in there. All right, you can practice making comparisons at home using other objects like I did today. I hope you have a great day today, and thank you for working hard. See you next time, guys.